Alam sir, good evening.
Good evening, sir. Can you hear me?
Yes, sir, audible, sir. So I welcome all the participants and esteemed speaker of today's session, Dr. Tabish Alam sir. So first of all, sir, I am very to deliver talk in this AICT faculty development program in clean energy and sustainability. It is my proud privilege to introduce our today's speaker. Dr. Tabish Alam is a senior scientist at Council of Scientific and Industrial Research, Central Building Research Institute, Roorkee, with expertise in heat transfer enhancement, solar thermal systems, computational fluid dynamics, and building physics. Sir has earned his PhD and MTech in thermal engineering from Indian Institute of Technology, Roorkee, and BTech in mechanical engineering from Aligarh Muslim University. Dr. Alam has held prestigious postdoctoral position at Indian Institute of Technology, Bombay, and Kyungpok National University, South Korea. Recognized for his outstanding contribution to research, he was listed among the top 2% scientists globally by Stanford University in 2024. Dr. Alam has made significant strides in sustainable energy and thermal engineering, earning accolades such as the Diamond Jubilee Based Technology Award for his innovative HVAC ducting system integrated with COVID-19 disinfection solutions. He is also a recipient of the Santi Sroma Sanyal Memorial Award for the best paper published in the Journal of Institution of Engineers Series A Springer publication. He is an active member of the Bureau of Indian Standards Committee CHD 27 on thermal insulation materials, contributing to the development of national standards. Dr. Alam is a member of the editorial board of Scientific Reports by Nature Publishing Group and serves as associate editor in Thermal Science and Energy Systems, Energy Efficiency in Building and Urban Environments, and the Journal of Engineering. With an extensive publication record in high-impact journals, Dr. Alam continues to advance energy efficiency and thermal systems through his research, editorial roles, and active involvement in standardizing efforts. So once again, I welcome you, sir. Over to you, sir.
Hello.
Yes, sir.
Thank you for introduction for this wonderful introduction. So now the today's topic of the lecture is energy efficiency. So I can share my slide.
Yes, sir.
It is visible?
Yes, sir. Is it possible to make it full screen, sir? Yes, sir.
Okay. So I can turn off my camera. Yes.
Yes, sir. Yes, sir.
So now it is visible?
Yes, sir. Visible, sir. Thank you, sir.
Okay, today's topic of this talk is energy efficiency in building. So why it is so important? Because we are living in a houses, building. So these are the one of the most important things we are availing. So energy efficiency, basically we have look the efficiency of the like cars, air conditioners, you know, washing machine. So there is so many equipment is where we can look the efficiency, but we are ignore the efficiency of the building, which is very important because a building is the very large consumer of the energy. So basically, the building energy efficiency that refers to the use of the design strategies, efficient technologies, operational method to reduce the energy consumption of the building while providing the required level of the comfort and indoor environment. These are the basically these are the four parameters we have to look for designing any building. First one is the environment impact. So what should be the environment can be affected by the buildings. Uh, the second is the economic benefit. The energy efficient building lower the operational cost through the reduced utility bills, which can lead to significant saving over the life of the building. Third one is the enhanced comfort and the health. So very good environment of the buildings. Everyone like that. We have to take the fresh air and contaminant less air. So this is the most important in environment, indoor air quality in the building. Fourth one is the security, energy security that relate to the overall energy demand of the building, help decrease dependence on the external energy sources and enhance the national energy security. That is how we are taking the energy from the external source and how we can generate the energy into the building, and that we are uh, utilizing the same. So these are the four parameters for can be which are very important to consider in designing the buildings. So now these are the chart where we can see which there is a number of the component of the energy consumer like HVAC, water heating, lighting, electronics, refrigeration, cooking, and other minor equipment. So you can see there is a chart for the commercial building and the residential building. In the commercial building, the most of the energy is being consumed in the HVAC system, and this is similar for the residential building. We can see that 36% of the energy is being consumed in the HVAC, heat ventilation and air conditioning, and the other part of the energy is being consumed like water heating, lighting, electronics, refrigeration, cooking, and other minor equipment. So you can see the trend of the energy being consumed in the building. You can see there is a approximately 10 times energy consumption in the building from 2005 to 2030. So you can see there is a residential building 5% increment is there. In the commercial and commercial office there is 8% in energy consumption is there. In the hospitalities like hospital, yeah, this hotels, there is a 10% rise is there. So these are the trend. So day by day we are constructing the more and more buildings. So this trend is going to increase. So basically, what we have to consider in the for designing the building that should have the low energy or net zero building. So first, we will try to reduce the heating demand, reduce the cooling demand, reduce the energy use of the lighting, reduce the energy use for the heating water, good housekeeping and people solution, reducing the energy requirement for ventilation. These are the some parameter which can help us to reduce the energy consumption into the building. So heating demand, how we can reduce the heating demand, how we can reduce the cooling demand, how we can reduce the energy for the lighting, how we can reduce the heating energy for heating water. So these are the some passive measures that we can implement into the designing of the building. So this can reduce up to the 40% of the energy demand by using these parameters. So in the next slide, we can see that the energy efficiency mainly depend on the passive technology and the active technology. In the passive technology, we have shown in the previous slide that the most of the parameters are the passive and which can be considered into the design of the building. That passive like the envelope of the building envelope should be in such a way that it cannot transfer the heat from building to outside or outside energy into the building. So it isolate that the passive term is referred to as the isolated isolation of the building from the external environment. So it does not escape the energy from the building to outer environment or energy from outer environment to the building. And the active technology that involve the using the energy to save energy, such as through the mechanical system or technology driven solution or integration of the renewable energy. In active technology there is a some other equipment like efficient HVAC system, efficient lighting system, efficient other efficient system, and the energy management system into the building. So these are the active systems. So we can see that energy saving meters in the building. We can see that in the energy saving technique, the building envelope design is the most important. That we have to isolate the building indoor environment of the building from the outside. So there is a proper insulation in the walling, roofing, so it does not escape the energy from building to outside and outside energy into the building. Uh, Second one is the heat storage system. So whatever the heat we are generating into the building, that can be stored, and when we have no energy, so we can use the lighting design. So basically the lighting design should be in such a way that we can use the natural daylight in the daytime. So these are the passive technologies where we can reduce the energy demand of the building. So other parameter is for the passive sustainable design is the building geometry, natural lighting, natural ventilations. Apart from this, cool roof, orientation of the building, and window sizing, window orientation, what we have to put the window on the north side, south side, east side, or the west side. These are the critical parameters which can reduce the energy demand of the building. Now the active strategies of the building that can be integrated into the building, like photovoltaic system that can generate the electricity for so utilizing the solar energy, or utilize solar thermal system that can use the energy from the solar, geothermal, wind turbine. These are the active technology. And the fuel cell that can be used for power the building, energy storage system. This come into the category of the active strategies. So basically, the term that we uh, in the lot of the news that come now coming into the news, that green building, net zero building, net positive building. So these are the similar, but there is a slightly difference is there. The green building is like achieving the balance between the energy they consume and the energy they produce, result in the net zero building, uh, energy efficient and renewable energy. So green building are those buildings that we have producing the some energy into the building, like solar, using the solar technology, wind technology, biomass. So and we also implement the uh, passive parameter into the building also. That is come into the category of the green building. Now the green building may be of two type: net zero building or net positive building. So net zero building are those buildings have which can generate the same amount of the energy which can be utilized into the same building. So what we are producing, we are utilizing the same amount of the building into the same building. And net positive, so this is the amount of the energy are producing more than the we required the energy into the building. These are the net positive. So suppose we have consumption in the building is 100 watts, so we are producing 150. So we are producing more than the consumption. So that are the net positive buildings. So you can see that uh, the in the various parameter of the in which are considered in designing into the building. The first one is the in the blue, in the yellow, that is the passive strategies. There is a number of the parameter which can be consider in designing the building. First is the building masses. Building masses that can absorb the solar radiation and do not pass it to the indoor environment. So thereby building can be cool. So solar energy does not enter into the building. The lot of the energy can be absorbed in the walling also. So this is the one parameter. Solar orientation is the play very important role for designing a building. So in solar orientation, it is in which we are designing the orientation of the windows, like uh, we have to put the windows in such location there is no direct sun radiation is there, which are more uh, important into the summer, where we energy is entered into the building, and but the same window orientation is desirable in the winter, where we need the solar radiation into the building. Third one is the building envelope. Building envelope is the uh, insulation is there over the walling, over the roof, so it does not enter the heat from outside to inside or inside to outside. So it's the this envelope, it protect the heat entering into the building. So thereby it reduce the heat load. Natural ventilation that utilize the fresh air into the building and does not require any refrigeration or air conditioning system. Natural daylight that can be used to reduce the artificial light. Cool roof is one of the most important, that most of the solar energy is penetrate into the building through the cool roof. So we have to design roof in such a way that it do not allow to the energy into the solar radiation into the building. Night radiative cooling is one of the most important, that can that can uh, release the energy into the night time to the clear sky, in the clear sky night. Low energy material, low energy. These are the important parameter in the. These are the passive strategies which can be used for reduce the uh, building energy consumption. So by using these passive strategies, 40% of the building energy consumption can be reduced. On remaining 60% can be e- for the energy, 60% of energy can be utilized by the some renewable energy renewable energy sources such as solar, wind, geothermal, biomass, BIPP. And for maximize the energy efficiency, there is a some efficient HVAC system, efficient lighting control, intelligent building automation system, shower drain heat recovery, and geo exchange. So these are the these are the max efficient system which can reduce the energy consumption, and then after we can use the active strategies for the remaining energy consumption, the HVAC, radiant cooling, heating, grid connection, load control, and the cogeneration. So in the passive strategies, we have discussed about the passive solar design, orientation, window placement, shading. Orientation we have discussed. Window placement is one of the most important parameter which can allow enter the solar radiation into the building. So window should be in such a way that it do not enter the do not allow to enter the heat into the building, but it can allow the natural daylight. That is the most important. The third one is the shading device. That shading device can be used to reduce the direct solar radiation into the building. Now the building envelope insulation, air tightness, double or triple glazing that uh, can be used for natural daylight, natural ventilation, cross ventilation, stack ventilation, ventilation tower. So these are the ventilation strategies to be adopted into the building to reduce the heating or cooling load into the building. Thermal mass material selection is the most important. Floor and with the wall designing, shape and layout of the building is also plays a important role. Compact design should be there for the design. Zoning is the important. Now the new concept is coming that the zoning, heating and cooling. So suppose we have a large, suppose we have the large hall. So in that we do not require the cooling or heating the entire hall. So suppose only 2% is sitting in the one of the corners, so we can uh, cool or heat the zone where we 2% are sitting there. Remaining the hall should not be conditioning. So this is the one of the most important concepts which are being used. Green roof walls, that is the green roof where we vegetated roof, green facades, other technology that such as like cool roof or other reflective layer on the roof is there, which can reflect the solar radiation. So these are the some strategies we in this picture we have shown. So in the passive house there is a window, double window, triple window, that which can allow the visual light into the building, but do not uh, cross this window. The heat does do not cannot cross this window. So there is a thermal insulation is there on the wall, so it does not allow heat from outside to inside, inside heat to the outside. And there is a thermal bridge is there. Thermal bridge, it is like a in the building structure there is a steel is there, so it's behave like a thermal bridge. When the high is steel used in the structure, so the heat chances of the heat escape from the building to the outside and outside to the building is more. So there is a minimum, their design should be in such a way that there is a minimum steel is being used. The air tightness, that do not air tightness should be there, so outer air does not enter into the building and inner air from the building does not goes to the outside. So these strategies can reduce the energy consumption into the building. So these are the active strategies: renewable energy, uh, integration of the renewable energy like solar, wind, geothermal, and using the efficient HVAC like efficient heat pump, variable refrigerant flow, and ERV by using a natural uh, uh, artificial efficient LED lighting that can run on a very small energy, daylighting, harvesting equipments using the occupancy sensor. So light would be on when there is a person is there, otherwise it will be off. So smart building control like building automation and management system, EMS. So after there is a some energy appliances can be used like air like efficient 5-star ACs, you know, efficient HVAC equipment, and there is a one option in the active strategies to on-site energy storage in the battery, in the heat storage. So we can use this energy into the building when there is no other sources there. So in the active system, there is a number of the renewable energy is there. Renewable energy is the energy that collected from the renewable sources that are naturally can be used on, and it includes the source such as the solar, wind, biomass, hydro, and the geothermal. This is the future of the energy that nowadays we are depending on. We are dependent on the fossil fuel like coal, nuclear energy, crude oil. So these are the alternate source that can be used and which can be renewed further for further use. So there is a several advantage like it saves the money expense. But if the initial cost is high, this do not uh, pollute the environment. So these are the basic uh, things in the renewable energy. So by considering all the parameter like building physics, passive parameters, active parameters, so we can design a building that will be net zero building and not net positive building. So we do not require any energy from the outside. So what we are generating, we can use the same amount of the energy. So there is a more renewable energy is coming into the market, that tidal energy, hydroelectric, solar energy, biomass, geothermal, ocean energy, uh, biogas, biomass. So these are the that renewable can be renewed at any time. So you can see there is a solar energy potential of the India, in which we can see the Leh Ladakh is the highest solar energy potential, and the second one is the uh, Rajasthan region. So although the temperature of the uh, Leh Ladakh region is goes below the 0 degree, or in the extreme weather condition is goes up to minus 40 degree, but the potential of the solar energy is highest in the entire country. So we can see that 4 to 5 kilowatt hour per day is the total energy in India, and this is the average one. So basically, the solar energy into the building can be used in two different ways. Thus, it can be harnessed this energy by a variety of the uses, including the electricity generation that can be used for providing the light, comfortable for air conditioning, heating, cooling. The other form of the energy is the solar thermal energy that can be used for the heating, for the cooling, for the water heating, for cooking. So we can see that solar photovoltaic that can generate the electricity directly, and but the solar thermal energy we can use the generated thermal energy into the various purpose. But although the this photovoltaic can generate the electricity, but the efficiency is too low. But on the other way, solar thermal system are the efficient system than the photovoltaic. The efficiency of the solar thermal system is approximately 60%. But we are depending on the photovoltaic system, although the efficiency is too low. But it is generating the high grade energy. So this solar power generation can be used in two different ways. One of the off grid, one is the on grid. In the off grid, we have to. This is the type of the independent of the grid system, so we do not require any grid. So we have the panel, we have the inverter, we have the battery bank. Whatever the energy we are generating, we can store into the battery and we are utilizing in the building. But on the grid system, there is a grid is there. What we are electricity is generating, we are fed into the grid, and we are taking the energy from the grid to the building. So this is the online system, on grid system. So these two systems have their own advantage and own disadvantage. So basically, I would like to talk about the solar thermal system that we are not widely used in comparison to the photovoltaic thermal photovoltaic collector, but the efficiency is high. So first one is the solar thermal collector that uh, use the solar energy and convert the solar energy into the heat. So solar thermal collector basically at the flat plate collector it has a four major component: absorber, glass housing, in the piping. In the piping there is a water flowing is there, and we have a absorber. This is the absorber and this is the glass cover. So when we are solar radiation is falling on the absorber, it gets heated, and below there is a piping system is there. Piping system is there. So in which the water is flowing. Water is flowing, so we can get the hot water. So these are the basic diagram to show what is the energy losses, what is the energy gain in this. So we can see that the energy input into the flat solar thermal collector is the direct radiation, diffuse radiation.
Left
So
side ने घेऊन टाकायला पाहिजे होतं, wrong side.
So we have this is the input solar energy, and what we are gaining the available heat from this part of this energy, and other energy is going waste into the environment. That is the convection from the back cover. One is the heat radiation from the glass or the absorber, and some of the energy is reflected back through this glass. So out of 100% solar energy, approximately 40 to 60% energy is can be utilized, and the lot of the energy is going waste. So the most of the energy is going waste into the top loss is top in the form of the top heat loss, because when we have the absorber at a high temperature is lose heat to the environment through the glass cover. So this is the uh, typically chart for the flat plate thermal collector. In this we can see the red portion is the energy which can be utilized, and this one is the thermal loss from the top cover or the side or the back side. This is the optical loss is there. So these are some equations to calculate the useful heat gain into the water. So the thermal efficiency, the useful heat gain upon the this solar radiation incident. So we have to remove the heat losses from the heat gain. So in which the parameter overall heat loss is most important. So overall heat loss is the summation of the top heat loss, back heat loss, and the side edges heat loss. Out of these three heat loss, top heat loss is the highest one, because most of the heat is lost through the top glass cover. So these are the some basic formula for the effective efficiency, exergetic efficiency. So basically, what are the important parameters that can affect the performance of the solar collector? That multiple. First one is the multiple of the glazing, transmittivity of the glasses, low iron glass, solar glass, low absorption of the solar radiation, anti-reflective coating, reduce of the reflection at the interface glass, ear high absorptivity of the absorber, and the first one, last one is that is the generating the turbulence into the flow that can enhance the convective heat transfer coefficient from the plate, absorber plate. Though this is the solar thermal collector, that is two type of the solar thermal collector is there. First one is the passive thermal collector. So in this collector, we do not using the any external power. So we have the collector, we have the overhead tank is there. So the in the piping system, energy is get absorbed and it transferred to the this overhead tank. So there is a natural circulation is there. Active thermal system is the thermal system in which we have to provide the external energy to operate this. So in this we have in the form of the electric, we are providing the electric energy into the pump so it can circulate the water, and we have the auxiliary heater so it can provide the heat when there is no solar radiation is there. So these basic two type of the solar thermal collector is available. These are the one of the example of the active thermal system like solar twin system. So basically, I would like to show that the system we have developed at Central Building Research Institute, we have developed the flat plate collector that the efficiency above is 60%, and it can the maximum outlet water outlet temperature is up to 95%. The and the maximum plate temperature is 150. So these thermal collector is designed and tested in the outdoor condition of the Roorkee. So basically, these are the some graph shown the what is the effect of the efficiency of the temperature rise parameter. So basically, these graphs shows that basically these are the comparison of the single glazing and the double glazing. So in this graph, we can see the efficiency is decreased with temperature rise parameter, but the efficiency of the double glaze is too high in comparison to the single glaze. And or we can see the heat losses for the single glaze is too high. So high heat loss through the glass cover means low efficiency. So these are the some data we have shown here. So these are the other result for effect of the absorbent temperature on the efficiency of different insulation. So these at different insulation we have taken these calculate shown the this efficiency. So the higher insulation has the higher efficiency. So these is the gap between the two places. So these are the results. So the other is the vacuum flat plate collector. Vacuum plate collector, that is the most important, that the flat plate collector, the most of the energy is going waste through the top glass cover by the natural convection. So in the vacuum flat plate collector, uh, there is a no uh, uh, air, there is a vacuum in the whole enclosure, and there is a flat plate is there. So when there is no air, so there is no natural convection is there, because natural convection is responsible for the heat loss. So when no air, so no natural convection, so efficiency is high. So the temperature of this plate is it reaches up to 350 degree. But in the previous system, we have seen that the temperature of the flat plate is reaches up to 150 degree. But we can see what is the advantage of this vacuum. So we are reaching the temperature up to 350 degree. So this is the another kind of the solar thermal collector that can be used into the building, that evacuated tube collector. There is a this also uses the vacuum technology. Heat is transferred to the transfer fluid of the domestic hot water in the heat exchange. Working fluid reaches up to 200 degree centigrade. So in this evacuated tube collector, we utilize the uh, this heat pipe. So basically, this is the heat pipe. So what is the advantage of heat pipe? The conductivity of the heat pipe to transfer the heat from this point to this point is 1,000 times more than the copper. So that why we can use this heat pipe. So basically heat pipe is the only like a tube that we can put one end at the one end the hot source, other is the hot sink. So it can transfer heat from hot source to heat sinks. So the basic working principle is that the vapor then travels along the heat pipe into the cold interface and condense back into the liquid, releasing the latent. Then this liquid is then returned to the hot interface through the capillary action. You can see here. So through the capillary reaction, and this recycle is repeated many times. So another this parabolic collector is like a compound parabolic collector that uses the direct radiation that are reflected back to the absorber tube. The working temperature of this absorber is 100 to 10,000, 100 to 200. So the advantage of this is the basic evacuative tube collector in which the reflector is placed, so it can utilize direct radiation as well as the reflective radiation from the this reflector. So this is one of the most important, and we are working on the PVD collector, photovoltaic thermal collector. So we have seen there is a number of the thermal collector is there. So with the help of the thermal collector, we can generate the thermal energy. But PVD collector is one of the system that can generate the electricity as well as the thermal energy. So photovoltaic thermal collector consists sometimes is known as the hybrid PVC system, and our system that convert the solar radiation into the thermal and electrical energy. This system combines a solar cell which converts the solar light into the electric electricity with the solar thermal collector. So actually, the other purpose is to cool the PV cell by removing the heat from the this uh, cell by using the thermal absorber. So it serves two purposes. One, it can generate the electricity as well as the thermal energy, and also by removing the heat from the uh, PV cell, the efficiency of the PV cell increases because the at the higher temperature of the PV cell, the efficiency decreases. So we are improving the efficiency of the PV cell. Simultaneously, we are work to generate the thermal energy. So this is the another type of the thermal collector, parabolic thermal collector. The thermal this through concentrated in the thermal collector, the it increases the solar radiation intensity on the evacuated tube energy. This absorber. So it's reflected the sun radiation into the reflected, and so thereby it is using the large amount of the solar radiation. So generally this uses uh, gener- generally this use for this is used for the uh, for high power plant, solar energy power plant. So the direct is heat solar energy into the building that can be used by using the thermal mass. So the solar gain is managed to harness the sun energy for heating purpose and to minimize the cooling season. That very useful in the Leh Ladakh region, and this is very popular technology which can be used in which can is being used in the Leh Ladakh. So there is a large window there, so direct sun rays enter into the building, and there is a thermal mass is there into the floor. So energy stored in this thermal mass in the daytime, and in the night time it releases the energy into the room. So indirect solar heating, which can be used into the building, that we have solar panel, we are storing the into the tank, so we can use in the night time. So this is one of the important technology that we are working in CBRI. So indirect solar heating by using the solar heating and solar cooling by using the radiant heating. So basically, radiant heating. The fundamental concept behind this, when there is a temperature difference is there, so heat is transfer from high temperature to low temperature. So in this cooling system or heating system, we have the panel on the roof or the sidewall is there. So we have to cool or heat the structure basically. So when the structure is cool, so heat transfer from human to this structure. So human is being the cool. So so basically there is no circulation is there. Only we are uh, in the room that the structure is being cooled. So there is a very efficient technology, and there is no fan is required, no ventilation is required. We are because we are using heating the cooling or heating the structure, building structure only. So this is the one of the technology that we have worked by 5 or 6 years ago. So this is the solar window is there utilizing of the solar energy through the solar window system for improvement of indoor environment in cold climate region for residential. So we have the steel plate is there, perforated steel plate is there, and there is a you can see there is a window is there. So this perforated sheet increase heated up by using the solar radiation, and this amount this solar energy is released into the room. So by using the purpose of the perforation to maintain the light, visible light, so naturally light into the room. So these are some graphs that we can show, we can see here the by using this solar window is there. So we can see the room temperature is slightly higher in comparison to the indoor uh, temperature in comparison to the when we do not have the this windows. So basically. Uh, So other technology for cooling to the building is the vapor compression cycle that we have the AC, we are running the AC's refrigeration system on the vapor absorption system. Vapor absorption system. In this system, we can utilize the waste heat, solar energy like that. So we have in this system we have vapor generator, absorber, evaporator, and the radiator. So in this we can generate the uh, we can use the waste heat and the solar energy eh, in the to release the ammonia from the ammonia solution. So in this ammonia is being used as a refrigerant. So other technology for the cooling the building is the desiccant based cooling. So 3 years ago we work on this technology in which we are major three component is there. One is the desiccant wheel. Uh, Second one is the indirect evaporative cooler, and one is the solar thermal collector is there. Solar thermal collector is there. So, wait, I will continue.
Okay, sir, no issue.
So in this technology, actually this is a solar air conditioner that is based on the desiccant base. So in this, uh, we are using the solar thermal collector, a desiccant dehumidifier, and the indirect evaporative cooler. So in this technology, there is a two stream of the air is there. One is the ambient air is going through the desiccant wheel where we can remove the water vapor from the water vapor from the desiccant wheel. Uh, then we have the recovery heat, and we have the indirect evaporative cooler. Indirect evaporative is like a desert cooler, but in the evaporative cooler there is no humidification take place. So there is a separate stream is there. So we are taking two step from ambient to the indoor air. So we are uh, We are removing the water vapor from in the desiccant wheel, and we are cooling the air in the indirect evaporative cooler. And when we air from the space conditioning is going going to the environment, it is going through the recovery wheel, heat exchanger where we have to heat this air, and we can pass through this hot air through the desiccant wheel. So whatever the amount is water vapor is being absorbed in this stream, it can be extracted by this hot air stream. So this heat is being generated by the solar thermal collector. So this is the basic concept. We have three major components. So we can see here there is a major component. One is the flat plate collector that have developed, which can be utilized to generate the hot air. This is the desiccant wheel. It can dehumidify the air and supply the dehumidified air. This is the indirect evaporative cooler where we have two steam. In the first steam, there is a water evaporation take place that can provide the cooling, and this cooling can be utilized by the dehumidified air provided by this desiccant wheel. So these are the major three components for this solar thermal air conditioner. So basically, what is the desiccant? Desiccant is a chemical composition that is used for the absorbing the moisture from the present air, remove the moisture, reduce humidity, improve air quality. Is so basically desiccant that absorb the humidity from the air, and then hot air supplied to the desiccant remove the air, remove the water vapor from the desiccant. So basic the desiccant material is the silica gel, that is the best desiccant material. So this is the basic layout that we have shown. This is the incoming air, humidified air. So it is passes. This is the wheel that is continuously revolving. So the incoming humidified air is passes. Humidified air is passing through the desiccant wheel, and dry air is delivered. So when this wheel is absorb this water vapor, so it gets saturated. So we have to remove this water vapor, otherwise it do not absorb the water vapor more. So in this, for this purpose, we have to passes the hot activated air at hot air at a high temperature, approximately more than 70 degrees. So it removes the water vapor from the this wheel, so it can be used for regenerate, can be reused. So these are the basic concepts. So silica gel molecular seeds we have used. So other the desiccant material, the activated alumina, activated charcoal, carbon, natural zeolite. So this is the indirect evaporative cooler. In the this is the direct evaporative cooler. This is the indirect evaporative cooler. We can see the direct evaporation is take place in the desert cooler, where we have the pad and the water is flowing over the pad, and we have the incoming air is passing through this. So this evaporation take place and air cooling down. Well, but the disadvantage of the desert cooler is that we cannot control the humidity. For this purpose, we develop the indirect evaporative cooler, where we have the two stream. One is the warm air is there, and another extreme is the air is there, and evaporation is take place. So this air is does not come into the contact with this stream. So we are controlling the humidity of this stream. So these are the advantage. Does not increase the humidity inside the room, can reduce the room temperature below the bedwell temperature, high energy efficient and low cost. This there is no compressor, so here it is energy efficient. Compressor is there, energy efficient compressor, less operation is there. This is one of the application of the solar air heater into the building, that way we can not into the building for the heating purpose. We can use this solar air heater into the drying the crops like this. So drying is a water removal process from the food stuff commonly used for the preservative and storage purpose. So these are the things we have worked. So these are the solar aerator drying is the water removal process from the food stock commonly used for the preservative and storage purpose. So we have also work on the solar radiator. There is a several component of the solar radiator. First one is the absorber plate. There is a glass cover, back insulation. The solar radiation falls on the absorber plate through the glass cover. So when the air is come in contact with this absorber hot plate, so it transfers the heat to the air and the temperature of the air is rises. So there is a blower is there, it sucks the air uh, passing through this air duct. So other technology, this technology is developed at the CVRA approximately 20 years ago. So solar the solar cooker have an insulated box here, and there is a double layer glass in there, and there is a reflector is there. It can cook items, uh, can cook two time items uh, like dal, rice, you know. So these are the some data. So it can also be used for the drying. So this is a very simple solar cooker, and the cost will be around. It is available in the market, and this is developed by CBRI. So this is a trombe ball. Trombe ball that can be used into the building for the heating purpose. In the trombe ball, it can be used for the ventilation as well as the for heating purpose. So we can see here there is a air duct is there, and the thermal collector is there. So in this thermal collector, uh, the by using solar energy is get heated when air is come in contact with the thermal collector. So the temperature of the air is rise, right, and same temperature of air is rises. So due to density difference is goes up. So when the this hot air is goes up, so it creates the stack air. So that will have to suck the fresh air into the building. So these are the basic concept that is being used in the Leh Ladakh, or this also uses for the heating the building also. So this is the one of the important, that is the solar chimney. The solar chimney of it has the same purpose like the Trombe wall. In the solar chimney that uses for the cooling the building. So in this we have the earthen channel is there. So by using this collector or solar absorber, so air heated up and it goes up. So it's create the suction, and it's create the it suck the air from the this earthen duct. Uh, so it's gets cooled down, and there is serve as a natural ventilation, also the cooling the building. This is a solar distillation system that for uh, removing the contaminant from the water. So solar radiation the heats up and remove the contaminant from the water and allow the water to evaporate, leaving the contaminant behind. This is a basic distillation system that uses the solar energy to evaporate the water, and that evaporated water can be collected at the end. So we can get the distilled water from this using this technology. The other technology to solar energy to generate the uh, thermal energy, that thermal energy can be used to run the this solar uh, thermal plant. for generating the electricity. So the through linear Francis reflector uses long thin segment for mirror to focus the sunlight onto the fixed absorber located at the common focal point of the reflector. These mirrors are capable of concentrating the sun energy to approximately 30 times its normal intensity. So this is the another type of solar thermal dish reflector, thermal collector that can focus the sun radiation on a particular receiver. So it's generate the temperature uh, approximately more than 500. So it can use this energy to various purpose. So this is the another type of the solar tower receiver that can be used to generate the electricity. Basically, there is a large number of reflector is there which can concentrate the solar radiation on a receiver. So it can generate the temperature up to 1,500. So by generating this temperature, high grade thermal energy can be generated and which can be used to generate the steam in the uh, power plant. So this is the another innovations that is being used in the US, Canada. There's a solar chimney. Solar chimney is the nothing but it is the chimney that uses the solar energy to generate the wind turbine. You can see there is the wind turbine. There is a large solar collector is there. So by using solar collector, the hot air is generated. So by it's creating the suction and it goes up. When it goes up, it's uh, drive that this turbine and it can generate the electricity. We can see there is a number of solar thermal collector we have seen in the previous slide, and we have seen the PVT technology there. So this is one innovation that has been done by MIT. So in this, you can see there is a transparent transparent PV panel. Solar cell is there. So there is a transparent and which has a very high application into the building where we can use this glass into the windows and it can allow to the solar visible light into the building and it also generate the electricity. So you can see that there is a light emitting diode is there. So when the light UV or NIR light is falling on the emitting uh, this light emitting diode, so it can transfer this energy into the this PV edge mounted PV cell. So it can generate the efficiency, but the although this transparent and generating the electricity, the efficiency is too low. So the work is being done on this. So there is another uh, innovation solar paint that can be used to generate the clean energy. Paint combines the titanium oxide already used in many wall paint with the new compound synthetic MS sulfide. So this is one innovation that in the form of the paint solar cell can be placed on the wall on the roof of the building that can generate the electricity directly. So this is one of the innovation that done by one of the sister labs CMERI Durgapur. So they develop the solar tree. Solar tree is nothing but the structure where the number of the module of the solar panel is installed on a particular structure in the form of the tree. So it can save the large amount of the land area. It's give 10 times more solar power conventional and compared to the conventional FPV layout consume 1% of the land surface for same power. So it is a high uh, applications where we have to use the solar energy. So this slides is shows the tri-generation system. Tri-generation system that um, in the tri-generation system, generally we want to generate the cooling, heating, electricity. Yeah. So the trigeneration system is simultaneously generate the electricity and useful heating and cooling from the combustion of the biomass fuel or solar heat. So trigeneration is an attractive option where we have to produce the energy as well as the heating or cooling. So in this system, single system can generate the electricity as well as the thermal energy or cooling for a particular space. So this is one of the important system of the trigeneration organic Rankine cycle that operate under a operating lower operating temperature and pressure than the traditional steam Rankine cycle. This allows a lower grade heat to act as a fuel. So this power generation by the organic Rankine cycle, it can generate the electricity by drive the turbine, and it can also generate the cooling and heating. This is one of the technologies that can be used for heating the space and cooling the space. The geothermal. Uh, so geothermal is nothing but that the uses the heat pump where we have to exchange the heat from with the ground because the ground have the consistent temperature throughout the year irrespective to the weather condition, summer or winter condition. So when the temperature, basically the air conditioner or heat pump has a high coefficient of performance when it exchange the heat from uh, thus exchange the heat with the which have the less temperature difference. So in this way we can utilize the consistent temperature of the land from the building, indoor of the building. So it can be used for the heating purpose, for the cooling purpose also. So basically, these are the some technologies that can be used into the building. There is we have a number of technology that we can directly use this technology like solar thermal collector, geothermal, trombe ball, direct solar heating, solar air heater, different type of the uh, uh, collect different type of the evacuated tube collector like parabolic throw collector or solar chimney that can be used for the generation. But what is the suppose we have uh, but how can we say that the building is efficient or not? So these are the some star rating that's come for the building, like ACs or washing machine or other small equipment. So building is also have the this star rating of the that building that depend on the energy consumption. So these are the few star rating available in the uh, building for the building in India. So building energy efficiency star rating for the building, green rating for integrated habitat assessment, Indian Green Building Council rating, lead in energy and environmental design. These are the basic uh, star rating available for the building in India. So we will show how rate the building, how we can say that any building is green, what is the star rating in that. So basically, the star rating performance for the building is based on the actual performance of the building in terms of the specific energy usage. So basically, kilowatt hour per square meter per year is the basic parameter that based on this parameter we can say that the building is green building or not. This would rate office building on 1 to 5 star scale, with 5 star level building being the most efficient and 1 star building is the worst efficient. Five the B rating is categorized for the five building: office building, hotels, hospital, retail malls, and IT are in five climate zone in the country that has been identified. So, what is this of the uh, climate zone? Warm and humid, composite, hot and dry, temperate, and the cold weather. So basically, the uh, office building in the following three climate zone for air conditioning and non-air conditioning, the star rating has been provided by the B. So we can see in this slide, this star rating for the office building has been uh, formulated in two way. One, when the building has the require building is air conditioning, 50% air conditioning of the building is there, and when the 50% is more air conditioning into the building is there. So you can see EPI. In the previous slide, we have the energy performance index, that is the kilowatt per hour per square meter per year. When this value 75 to 65, so 1 star building is there, that should be 1 star. So in this way, when this the lowest EPI is there below the 35, so 5 star building. This is particularly for the hot dry when the air conditioning is 5%, less than 5%, 50%. Warm and humid in the climate zone. So there is another rating is there when the uh, when the EPI is below 45, then the 5 star rating is there. In the composite line, there is a different star rating is there. So you can see in the beginning of the presentation, we have seen the most of the energy is being consumed in the HVAC. So this in this way, the BE has formulated this star rating for two types of the building. One, when office building, when we have air conditioning less than 50% and we have a air conditioning more than 50%. So you can see there is a difference in the EPI. So for the 1 star rating, there is a EPI required 75 to 65. But when their air conditioning building is more than 50%, then EPI suddenly more than 2 times. So this is the effect of the air conditioning. So in this way, sorry. So in this way we can see what is the effect of the air conditioning into the energy consumption. So this star rating for the BPO building. So you can see 5 star rating for the warm humid climate when there is EPI is less than 30. Composite for the composite, it should be less than 28. For hot and dry, it should be less than 13. And for the temperate, it should be less than 23. So basically in India, there is a number of the green buildings. You can say net zero building has been designed and has been operating in the different part of the country. These are the few examples. One is the Indra Paryavahan Bhavan that is located into the Delhi. So this is 7+ story plus, and it has the three basement. So it is a net zero building. There is a number of technology installed in the this building, that rooftop solar PV. The total area taken by the solar panel 4,600 square meter, annual energy requirement and generated 4 lakh unit kilowatt per hour for this building. The other building, Godrej plant, 13 NXC. So this is one of the uh, green building that 45% less is it consumes the energy 45% less from its projected API. So this is the building that is located into the Hyderabad Infosys campus. It has 2,40,000 square feet in Infosys building in Hyderabad, and it has a innovative cooling strategies like radiant cooling, half standard VAB system. Radiant section uses 33 less energy than VAB, despite although this has a higher occupancy, but it is the energy consumption of the building is uh, low. So it is a five-star building and a green building, net zero building. So these are the few uh, uh, this the application of the how we can design the green building. So we can see in the whole presentation that first we have to consider the passive parameter, where we can use the orientation of the building, building in block, and thermal mass, and up to 40% of the energy of the building can be reduced only by the passive measure. The remaining 60% of the energy
आ रहे हैं ना
consumed
गौरी? Sure.
can be utilized with energy sources
Right?
that can be created into the building. So with this word, I can stop here. If anybody have any doubt, any queries, any questions, so I will be happy to answer you.
Thank you very much, sir, for enlightening us related with the utilization of solar energy by different ways. So now I request all the participants uh, kindly ask questions if you have, and kindly raise your hand. We will call one by one. So Dr. Jyotindra Kumar Pathak. Dr. Pathak. Okay. Mr. Manish Thakur.
Yes, sir.
Yes.
Dr. Pathak.
Yes, Dr. Pathak. You want to ask any question? Dr. Pathak? Manish Thakur?
Yes, sir,
You want to ask
I want to ask one
some
question.
question? Yes,
Actually,
Please.
if we compare the conventional solar panel system with the tree type structure, then in terms of surface area, if the surface area of both can be taken as same, and in terms of efficiency as well as in terms of bottom area. First, this enlighten this, and the second question: what is the cleaning mechanism used for the cleaning purpose of tree-type solar system?
Actually, in the tree type solar tree, there is a structure is there. All the panel are placed on the this structure. So it is designed in such a way that the shadow of the one panel do not affect on the other panel. So there is a, if you will see, it do not use any land because it is in the air. If you will install these panel onto the land, so all the land is occupied, but there is a only the major foundation or the structure of the building is there. Major foundation and the structure of the piping of there is there, so it does not require any land. You can say there is a very small portion of the land it are using. So with the, so you can see, you can imagine that in the agricultural land it can be used. And because the from the from morning to evening, from morning to evening the sun is rotating. So the shadow from one panel to the other panel does not affect its performance. The Although the performance, this is the same panel, the efficiency of the single panel is same, but the output in term of the land is too high.
And what is the cleaning mechanism which can be
Hello.
used for?
No, actually, there is a number of cleaning processes there. There is a in CBRI, we have a one division, cars construction automation mechanization system. So they develop the mechanization system for the facade of the building. So that system can be used for the PV panel. And there is a other lab, our other lab, CGCRI Kolkata is there. So they develop the anti y- you can say one type of the coating is there. So that can self cleaning coating. It is known as the self cleaning because the dust particle, other particle do not stay on this coating is there. So there is a number of technology available for this cleaning purpose.
Okay, sir. Thank you so much.
Dr. Amar Kumar Das.
Good evening, sir. Hello.
Good
Good
evening.
evening. Yes. Hello.
Heating purpose as well as power generation. But I have seen
Hmm. Hello. Hello.
systems. It's a hybrid one. I just
Can you
want to
Dr.
know.
repeat your
Amar,
question?
yes,
Hello.
you are not
Am I
audible.
audible?
Please repeat your, or type your question. Your voice is not audible.
You are not audible.
Please type your question in chat box. I
Hello.
will ask on behalf of you. Yes, yes.
Sir,
Yes,
sir,
yes,
am I
now
audible?
audible.
Abhishek sir.
Yes, yes.
Abhishek sir.
Yes, yes,
Am I
audible,
audible?
audible.
Yes. Yes.
Ah, yes. Yeah, yeah. Sir, my question is, in the last lectures, we have already studied there is some dual facet of power generation as well as heating, where we are using the
Hmm.
solar panel for the dual purpose. My query is
Hmm.
related to the slide what you have just earlier shown,
Hmm.
where you have shown both the heating, cooling as well as the power
Hmm.
generation.
Yes. Yes.
So my question is, how much it is effective if we are using a solar panel for both the power generation.
Hello. Hello.
Dr. Amar,
Yes, sir.
You.
Okay, sir.
your voice.
Sir, I'm using. Okay, sir. If I am not audible, I can put the question in the chat box.
Yes, yes. You put question in chat box. I will ask.
Okay. Okay. Thank you, sir.
Yes. Any question from any more question?
Yeah. This is I'm Sridhar Ramu.
Yes, sir. Yes, sir.
Can you listen my voice?
Yes, sir.
Yes.
Yes, sir. Audible, sir. Please, sir.
Sir, you are talking about green building.
Hmm.
Yes.
Yes.
So actually, in India, we have seen that a lot of multinational companies and huge constructions, they are using glass for the
Hmm.
elevation, beautification of the buildings.
Hmm.
Okay, but these glasses can increase the global warming.
Hmm.
Yes or no, sir? Am I right?
Glass, you can see that these glass are responsible for the energy consumption into the building. You can say this. These are not directly uh, responsible for the global warming, but you can say that they using the glass, the consumption of the building is increasing. That, and that's depending on the fossil fuels. Electricity that's comes from the plant running on the fossil fuels. You can say in this way, but now the technology, lot of technologies are available that the efficient glazing system that do not that can not allow the heat from outer side to the indoor of the building. So it allow only the visible light, like double glazing, triple glazing, or the glazing that double glazing that filled with the inert gases like argon, krypton. So these are the most efficient glazing is there that do not allow the heat from outer side to inside into the building, but only allow to the visible light. So the scenario is changing nowadays.
Okay, okay. But I came to know that in Hyderabad particularly,
Uh,
the where such buildings are there,
uh,
where the more glasses are used for the elevation,
Basically, you are talking
areas
about
the temperatures are high.
you can that is the another term you can say the Iceland. That
Uh,
is the solar energy reflecting back from the building due to the reflections of from the glass. So it's creating the heat island. You can say this. This is the problem.
so
This is the,
because of the high temperature inner the room,
Hmm.
people are using more air conditions. The
Uh,
more air conditions again leading to global warming. So, do you suggest this kind of glass elevations to our Indian conditions?
देखिए कहीं ना कहीं आपकी एनर्जी तो जाना या तो बिल्डिंग के अंदर जाइए रिफ्लेक्टेड बैक होगी है
But
ना
this glass is reflecting. This is making.
ग्लास
Uh,
इज रिफ्लेक्टिंग आई एम एग्री विथ यू I
uh,
am agree with you. So if we are absorbing the energy into the building, then we have no heat island. If we are reflecting the heat from the building, from the glass, so we are cooling the building by inefficient way. So this is one advantage, and also this is the one disadvantage also, because there is a actually glass. Uh, as a green building expert, I do not suggest the glass for the entire facade, because we suggest the small window,
yeah.
so it do not reflect the more heat to the environment.
But unfortunately, here for multinational companies, they are using more this glass for the front elevation. Some
Actually,
multinational companies
this
completely use glass, but
actually one you can see in the most of the practice is like that. They have the glass, and they are placing what is the use of the glass if building is looking beautiful, na, the
yes,
first purpose is that na the building is looking beautiful. Second purpose is to take the advantage of the natural daylight into the building. That is the second one, you know. But we have the glass and we are using the blinds. What is the purpose of that? Second purpose is goes away.
Mm. But I think this kind of glass is suitable for the cold countries, according to my knowledge.
All countries के लिए we can do, but in the hot there is a some problem.
Yeah. Okay. Thank you. Thank you.
Then,
Sir, one more question from Dr. Amar Kumar Das.
Mhm.
Uh, he is asking how effective the PV integrated system, including cooling and heating. how the power or load sharing take place.
Actually, if you are talking about the PVT collector,
Yes, sir.
photovoltaic thermal collector,
Yes, sir.
basically it is effective, but the you can say the efficiency of the PV panel is around right now the whatever the PV panel is available efficiency of approximately 15%, and the it 85% is energy is going waste. So these energy can be trapped using the thermal absorber into the PVT. So these thermal energy can be used for heating or the cooling also. But the problem in the system is that the when we use the heating, that is okay. But when we use this heat for cooling, that the system cost is too high. So initial investment is to, although we can do the cooling also with the heat, but the initial cost is too high.
Okay, thank you, sir. So thank you very much. Any question? Any more participant ask any to any question? Okay. So thank you very much, sir, for enlightening us about the utilization of solar energy by the different methods, and by sharing your practical experiences. We are very thankful for accepting our invitation and delivering talk in this faculty development program. So thank you very much, sir.
Thank you. Thank you.
So small notice to the participant. Next speaker is from Ajao University, Dr. Manmohan. So we will take 15 minutes break, tea break, and we will start the next session exactly at 7:45. Dr. Murli, please switch,
Yes, sir.
stop the recording. And
Yes, sir.
really, I am
Okay,
very
sir.
much thankful to all the participants. Kindly do join at 7:45 and enjoy the session from Dr. Manmohan.